Okay, can you see now?
Yeah, we can see now.
Okay, I had this presentation today as well in the J. Marriott for some ministers and other people of the industry, talking about decentralization of biofuel and char. Now, the decentralization is there because the minister also mentioned the transportation cost of all the biomass materials is what kills the business. And we know that because we have been looking into this quite some time. And together with the university, we have developed a catalytic depolymerisation to convert the biomass into biofuel, liquid and gas, as well as char as a solid product. Now, catalytic is required in order to keep the capital expenditure low and also make the plant smaller. Now, when you make the plant smaller, you can decentralize it because you don't have to move it very far away from the biomass. You can put it in the neighborhood, and therefore the transport cost will be minimized. Now, we call this a threefold catalytic plastic biomass to oil approach because reducing the transportation cost is paramount for the future of profitability. Lowering capex is necessary to make it more adaptable so that it can be multiplied much faster than if you have to look at the large investments of 50 to 100 million. And the third part of this presentation is we are getting gas and oil and char, but these products have a value that can be maximized, and it's required to do so in order to have the profitability at hand. So what we do is we start with shredding and separation, wet and dry. The reason for that is many approaches, they have wet biomass and need to get rid of the moisture. Now, this is normally expensive because you have to spend energy and that reduces your operating profit. So what we do is when we do the shredding, we are squeezing the biomass to remove all the wet mass. It becomes like a slurry, and we send that to an anaerobic digester. The reason for that is anaerobic digesters work wet, so you don't have to remove the water. Now, for the solid part, which can be plastic, frankly, actually, solid green biomass is natural plastic. We have added the artificial plastic to it, but the CC bonding is still the same. For that solid part that doesn't have much water, we use a catalytic conversion to make oil and biochar out of it. It has to be catalytic in order to keep temperatures low, which makes the equipment cheaper. Also, the amount of oil and gas is higher, especially with a fraction of oil being more preferential, so that you have to get more energy that you can sell. And third, now we have gas and oil which we can sell, but in the end, the finished product is the energy you create out of it. And for that, we have developed a new type of engine that can do 30 to 50% higher conversion rate of any fuel into electrical or motion energy. Now, I show you some samples of what we have done so far. What you see here is a biomass digester. This is done together with a stem-owned company called Aramco here in Malaysia. Is a containerized or container-sized unit. What you cannot see from outside is that it is not a simple tank as most biodigesters are. This one here has an internal structure which is similar to a plug cell. The reason for that is because the different bacteria to do anaerobic digestion, they require slightly different environments. And in order to achieve that, a plug flow system is better because you can have a liquid with different concentration at the beginning, at the end, and you can refurbish the gas from one section to another section in order to maximize bacteria growth. That way, you reduce the residence time. That means that you don't have to wait so long for the material to be all digested. And that obviously saves space and capex. Now, what you see in front there is our shredder and conveyor to put in the biomass. And in the corner there, you see the blades that we are using. This is just an example of how we innovate. The blades there are designed to minimize plastic entanglement. So normal shredders, they have plastic bags all getting wound up around the shaft, and then you have to stop and remove all the blades. In our case, we have blades that do a cutting process, so the plastic gets cut and removes itself. Secondly, you can see these blades are not full circles. Why? Because with this construction, we can actually take out the blades and sharpen them without removing the shaft. So we are saving a lot of manpower and man hours in order to service our shredder. It's the first shredder of this type in the world, actually, and is commissioned for Alam Flora here in Malaysia. Now, in this slide, you see the machine that we are using to convert the biomass or the plastic into oil. You see a screw press here in the center with two input hoppers. The first input hopper is for the biomass or the plastic or both together with all the water. Now, when the screw is running, it squeezes this material and reduces the volume drastically by factor 10. At the same time, it removes the water so that it can be pressed out like a slurry and be transferred to the anaerobic digester. But most importantly, it also seals the material towards the final reactor so that no air can go in. This is a big issue in many pyrolysis plants. They have air and then they create a combustion. Combustion is also called in Germany hot renovation because you have to build a new plant. Anyway, so what we do is we are forming a plug that seals off the air. We compress all the solids, and the screw itself, together with outside heating, creates heat inside the material that exceeds 300 degrees. Therefore, we have a second hopper, seen here, where we add catalyst. So when the water has been removed and the catalyst is mixed into the material, it starts cutting the carbon chains to make oil and gas. Now, for biomass, we get typically 20 to 30% oil. This catalyst that we develop is also able to do empty fruit punch, which is a very easily available biomass in Malaysia because of all the palm oil mills. And this particular biomass has high lignin content, which normally does not allow it to be easily digested. So for this particular catalyst, we have achieved up to 30% conversion rate with empty fruit punch. Now you may ask, what about the plastic? And it may surprise you, but plastic is way easier to cut into smaller pieces with the catalyst than you can do that with biomass. So for plastic, we have a conversion rate between 60 to 80%. So down here, you see the team from the university. And on the next slide, you see actually the machines that are currently in operation. The first machine where you saw the bucket had rice husk inside. This machine is also a screw, and it uses the rice husk to convert it into a catalyst. So we are actually also making the catalyst from a renewable resource. So when you look what is coming out there in the bucket, this white powder is the base, the bulk base of the catalyst we are using. And it is made purely from rice husk. The design of the equipment also is done by us. The work on this started about 15 years ago. So this is actually the third version of the machine, which is much larger because we are slowly going into commercial production of the catalyst, so that we also can have enough catalyst to make enough oil. The second video where you see a similar machine is the screw press that makes the oil. So here you see some steam and wood vinegar coming out. The oil is collected down here. And with this equipment, we have verified the amount of oil we can get from empty food bunch. Now, at this point in time, we have oil and gas. But you can't do much with oil and gas. You need to combust it in order to either create heat or motion or electric energy. Electric is now very popular because everybody talks about electric cars, but not all the energy will come from solar and wind. There is a large amount of waste that need to be additionally made into energy in order to sustain the energy demand that we currently have. And because of this, we have been looking into engines since more than 10 years. I had my first talk about engines with Mercedes research leader, Dr. Hart, like 7 years ago, and we offered him to do a cylinder head with only one valve, not 5 like Yamaha has. And he said, Dr. Cropp, I can't buy this from you because the last time we bought something like this, we bought the Wankel from NSU and we couldn't get it working. So we sold it to Mazda. So I said, okay, let me think about it again. And I was looking into why the Wankel wasn't really successful. And this is how, in the end, we came up with a new engine concept. Now, I won't disclose here to you how the engine actually looks like. This has to do with patenting and with trade secrets. You will see it early enough when it's in your hands or in your next car. It may take another year or so. But what is important is we have designed this engine to create more power output from the same amount of biomass than before. We are estimating 30 to 50% based on calculations compared to a normal engine. That means efficiency goes up for a petrol engine that is run on biofuel from 28% to somewhere between 45 to 57. On the side, you see a normal engine with a cylinder head and a crankshaft. And then you see a green and a yellow circle. The green and yellow circle depict the size of our engine for the same power. No, for the same displacement, to be correct. For the same displacement in comparison to a normal engine. For the same displacement, we do have twice the power. Why? because we don't have a 4 or 2 stroke, we have a 1 stroke, which means we have 1 explosion for every single turn, which for the same speed of the engine gives you immediately twice the power. Now, because of the efficiency, we also have half the waste. And importantly, we have the possibility to use all types of fuel. We can use petrol, diesel, LNG, CNG, LPG, biogas, and also hydrogen or ammonia. Now, let's come back to the name, because you may ask, what is this funny name about? And is it all fake news that Dr. Cropp says he has an engine that can do more power output, since so many people have tried and are still trying? And it's correct. People have tried, and some have good engines, and they are slightly better than before. The reason that I was lucky enough to find something else is because I don't look at an engine simply as a mechanical engineer. I'm not a mechanic, I'm a chemical engineer. So I look at it as a reciprocating batch reactor. You put chemical energy in there, you perform a reaction, and you want energy to come out. And how many % is what counts the most. So looking at what is all wrong or not that good in existing engines, we have redesigned this process. So when we call this engine HyperX PTT, we mean hyper expansion. That means your normal engine compresses 1 to 10 for petrol, 1 to 20 for diesel. And then you have an explosion and you decompress in the same way. You can't change that, but we can. So we compress 1 to 10, but we decompress 1 to 40. Now, what does that mean? It means when we open the exhaust, there is no more pressure left, because the pressure has all been converted into motion, which means more energy is available at the crankshaft to be converted into anything else. At the same time, you don't need an exhaust or a silencer anymore, because there is no energy left to make noise. So based on that, already the engine becomes cheaper. Now, the other thing is, we like turbines, yes. But turbines have blades which have a space in between them. And when you send the medium in through there and you hold the shaft, the medium will still go through. That is also the case if you don't hold the shaft, but you just take power off. It's called bypass loss. If you have a piston engine, it's a positive displacement engine. It's all sealed. So you stop the shaft, nothing goes through. Now what we have here is actually a positive displacement turbine. That means it functions almost like a turbine with almost as little friction as a turbine. But when we hold the shaft, no medium can pass. This alone creates an additional efficiency of 8 to 10%. Okay. No exhaust noise, I already mentioned. All the parts are not required. Now, one more thing. All your engines, they have cooling systems, because you don't want your metal to melt away while you're running the engine. But this heat is normally cooled away from the engine in the form of warm air behind your car. In our case, we also use the cooling, but we put it only on the hottest parts and make steam out of it. Now, guess who also did steam and made an engine out of it? That was James Watt. He invented the steam engine. So we are using his principle to create steam and run the engine instead of using fuel. That means we have 1, 2, 3, 4 fuel cycles, and then we have 1 cooling cycle. So if out of 5 cycles, we use 1 steam, we already save 20%. Now I mentioned the engine is similar to a turbine. It has almost as little wear as a turbine, which also means more power. On top of that, it means you don't have to repair it. It will last longer than a piston engine, which has piston and piston rings rubbing against a cylinder wall, causing power losses and require replacement or refurbishment once in a while. So this engine has less of these issues. It will most likely last up to 2 to 3 times longer without any refurbishment. This saves cost for the operator. It improves reliability. It reduces downtime. Now, I mentioned to you, we can do multi-fuel. You may ask me, how can you change from diesel fuel to petrol or the other way around if you have to change from a spark plug to a glow plug or whatever else? That's a good question. And we don't want to do that. So what we did is we re-engineered the spark system so that we have a spark system with less parts, with a tiny electrode, running on a small, tiny lithium-ion battery, but it's firing not just once, it fires hundreds of times per cycle. And it can ignite any fuel. Why do I say that? If you take your spark plug from the car and put a piece of paper between the electrodes, the spark may go through to the paper, but it won't ignite the paper. But you now look at this. This to you, hopefully, is enough visual proof to believe that we have done something beyond the normal car engineering and that we can ignite any fuel, no matter whether it's diesel, petrol, nitrogen, ammonia or hydrogen. It doesn't matter. This is hot enough to guarantee we ignite it. Okay, some more details here. Because it's a one stroke, we have immediately double the power at the same RPM, which means we can build smaller engines for the same type of application. Because of the steam, as well as the hyper expansion, together with the low friction and no bypass loss, we estimate 30 to 50% higher efficiency. In terms of putting this engine into an application, if one cylinder is not enough, the engine is modular, they can be stacked. And I should mention one more thing. We do not need the gearbox anymore. The reason is we can run this engine at 20,000 RPM, but we can control it to have only 2,000 emissions, which means that is exactly what your gearbox does. By reducing the gear, you can run 200 kilometers per hour on your car with 2,000 RPM. And we do the same with our engine by having 20,000 RPM, but only doing 2,000 emissions, which means our fuel consumption is the same as if you had the gearbox. However, the gearbox is almost as expensive as the engine, sometimes even more. The weight is also more, and all these parts and all these costs can be saved. They are not required anymore. So no gearbox required, no exhaust required, no complicated cooling system required. And also the engine with half the size can have the same power. The savings are dramatic. We believe this will be the engine of the future and replace almost any engine that is currently out there. It will take some time, but it will come. One last thing. Everybody is talking about electric engines. Yeah, we like electric engines. And an engine that do combustion work also needs an electric motor, at least a starter. However, seeing the demand, we have put our thoughts together to design an electric motor that is compatible with this engine. So it's also modular, and it can be simply flanged on. Other people's motors also can be flanged on. But in our case, we have designed an electric motor that is similar to Koenigsegg or to Yasa, which is actual magnetic flux. Because of that construction, we can have a pancake type of motor where we add modules to make it larger or smaller, depending on how much power is required. So that way we minimize the size, and because we can avoid using iron or magnets, we also can reduce the price. This is also something very new, and only recently we have concluded the final drawings to get it into place. I would like to leave you with one thing to consider. No matter what we all do, in the end, we earn money also to enjoy. To enjoy, we need to have a better environment with less plastic flying around, with less rubbish. But in order to have a better environment around, we all also first need to have a better thinking of within. Thank you very much.
Yeah. Thank you. Thank you, Dr. Richard Cropp, for an excellent presentation. So, is there any questions from audience to ask Dr. Cropp about his hyper engine or his
yeah, I've got
questions?
a two-part question, if you don't mind.
Yes.
So yeah, a great presentation. It sounds like you're doing some innovative work. So I'm a diesel fitter by trade. I'm a mechanic. And yeah, I've certainly seen a few engines that can run on various fuels. That's certainly easy enough with 2 and 4 strokes. The thing that I'm confused with is you say it's a single stroke with a high, potentially high compression ratio, but you also say it's like a turbine. So I'm just trying to understand, is it rotary or is it linear in the piston?
That's a good question. I forgot to mention, but that is why I put the drawing in. It should depict rotary, and it is a rotary. However, however, it has no similarity whatsoever with the Wankel.
Sure. Of course. My other question, so to have combustion, you're obviously drawing in oxygen, but you're saying there's no exhaust, no emissions. I'm trying to understand, where does the CO2 go?
Okay, I did not say no emissions. What I said is you have an exhaust in the form of an outlet where the combusted gases are being left out of the engine. But what you don't need anymore is a silencer.
Right.
So you don't need a muffler, you don't need a catalyst. Actually, you don't need a catalyst, partially because 1 stroke means we have a full power stroke for 360 degrees in this engine. And that is enough to give enough time for the same RPM. For the same RPM, it gives you twice the time to do a proper combustion.
Sure.
So that alleviates the need for a catalyst.
Okay. No catalytic